Okay, dear student, let's see what is there in this question now. A cell of an EMF 17 volt and the internal resistance R is connected to a two 10 ohm external resistors as shown in the diagram. There is a current of 1.5 amperes in one of the external resistors. What is the value of the internal resistance R? Now this is November 2024 exam that we are doing, and this was I believe the last exam from the old syllabus. So in old syllabus there were two topics, like number one is the Kirchhoff's law and another is the terminal potential difference. So Kirchhoff's law is clearly removed from our new syllabus, so we can get rid of that, and I will not be teaching you the same thing with the help of Kirchhoff's law now. But the terminal potential difference is in a bit of I would say a gray zone kind of thing. So it is clearly mentioned that the terminal potential difference is no longer in your syllabus, but there are some questions which you cannot be solving without the help of terminal potential difference. And also this topic is not omitted from any of the book. So all the books and different authors, they are still teaching the concept of terminal potential difference. That is why this topic is bit gray zone. So even if you are in the new syllabus, this question is very important for you. So listen to me. Now, so it is given this is 10 ohm, this is also 10 ohm, and one of the 10 ohm is getting a current of 1.5 amperes. Now, whatever happens to the battery here, the EMF is E, the internal resistance is R. If this 10 ohm and this 10 ohm, they are in parallel with each other, they will be having the same potential difference across both of them. And because they are having the same resistance, they are having the same potential difference, they will be having the same current which is passing through it. So even this will be having 1.5 amperes. So what is the potential difference here? V is equal to IR. So the current is 1.5 and the resistance is 10. So it becomes 15 volt. It means that the voltage across this is 15 volt. Similarly, the voltage across this is also 15 volt. And by the way, all these three things, they are in parallel with each other. So we can even say, we can jump to this conclusion that the potential difference across the battery will also be 15 volt. Now, how is the terminal potential difference defined? Terminal potential difference is defined like this. Like this is the battery, this is the resistor, internal resistance R, this is EMF E, this point is A, this point is B. It says that the potential difference across A and B, it means VA minus VB, is known as terminal potential difference, and the formula for that is E minus IR if current is withdrawn from the battery. Now if you say that current is not withdrawn, it is going into the battery, it is charging the battery, then there is another formula. For charging, it becomes E plus IR in the case of charging, and this is in the case of withdrawing the current. I hope that is clear now. So if you want to have some lectures on it, all the lectures for the topic B5 are available on YouTube channel, but you got to become the member on the YouTube channel to access those videos. Okay. So this is terminal potential difference. Now here, this is E, this is R. So yes, the current is withdrawn from the battery. So battery is losing its current. There is no problem, no doubt about it. So terminal potential difference is E minus IR, and the terminal potential difference will be equal to 15 volt as we have already seen. So it is 15 is equal to E is 17 volt is the EMF which is given, minus I into R. Now what is the current? So 1.5 ampere is going in one current, resistor 1.5 in another. So total current is 3 and this is R. This is how we do it. So 3R is equal to 17 minus 15, which becomes 2. So R value is 2 by 3. So this is the internal resistance. This is how we do this question. Let us see if that option is available. Yes, C is the correct option for this question, and this is how we do this question. So I'm repeating the thing again, that there is the concept of terminal potential difference, which was removed by IB in the new syllabus guideline, but still it is in the gray zone. So I will not advise you to skip that topic. This is the topic, you have to remember it. Just keep it in somewhere in your mind. There are two formulas. One, when the current is moving away from the battery, so it will be E minus IR, and the other will be E plus IR. Okay, dear students, all the best. Bye.